Good morning, sir. My name is Christina, number metric TE230075, and I am going to present about task 1. So, for task 1, a mechanical system is represented with an RLC circuit as shown in figure 1. Yes, this is figure 1. So, we assume the current source IS is 8 ampere is applied to the circuit, and initial current IL0 and the initial capacitor voltage VC0 are both 0. So, at this question, we need to design the circuit to obtain an overdamped circuit, critically damped and underdamped response. So for the design, we need to choose an undamped frequency W in the range of 100 to 1000 RAD per second. So at here, I set the W as 1000. So after I set the W as 1000 and I can find the calculation, so I set W at 1000 and L at inductor as 10 mH and IS is 8 ampere and IL0 is 0, VC0 is 0. So at here, I apply the formula W equal to 1000, 1 over square root LC equal to 1000, and from here I can find what is C. So after the calculation, C is 0.1 mF. So at overdamped case, we know that alpha must be larger than W. So I assume that alpha is 1500. So at here, alpha is equal to 1 over 2 RC. And we already find C, right? So alpha is 1500. 1500 equal to 1 over 2 R, 0.1 milli. So after the calculation, we can get R equal to 3.33 ohm. So after that, we need to find S1 and S2. So after we sub the value that we get inside and the alpha and W that we assume, and we can get negative 381.97 for S1 and negative 2618.03 for S2. So after that, we sub the value inside. So IT is equal to IS plus A1E S1T plus A2E S2T. So we sub it inside and it will become 8 plus A1E negative 381.97T and plus A2E negative 2618.03T. So after that, we know the initial condition I0 is equal to 0, right? So we need to find out what is A1 and A2. So we apply the initial condition inside. And as T is 0, so from here T is 0, so E is power to 0. E power to 0 is equal to 1, so we can just simplify it at 8 plus A1 plus A2 equal to 0. So A1 plus A2 is equal to negative 8. So di dt. What is di dt? So di dt is d dt bracket the I. What is the I? This thing is we get for I. So after that, we just differentiate it lah. So we can get this equation. Then after that, we also sub the initial condition, that is t equal to 0, and we can get this. Negative 381.97 A1 minus 2618.0382. So V is equal to L di dt. After that, we sub the value we get inside, and so V0 is equal to 0, right? So 0 equals to 10 amp bracket the answer that we get from here. And after that, from 1 we can find out AE1 equal to negative 8 minus A2, and we sub this thing inside this, and we can find out A2 is equal to 1.3666, and we sub the value inside, and we can get A1 is equal to negative 3.3666. After that, we sub the value inside IT equation. So after we sub the value inside IT equation, for now we need to also find the VCT, right? This is ICT equation. I mean ILT equation. So VCT equation equal to L di dt, and we just times 10 milli inside, and we can get this. Okay. So after that, for critically damped equation, critically damped response, we let the L become the same thing, and W is equal to 1000 also. So after that, we can find out the same thing. C is equal to 0.1 mF, and since it is critically damped, the W naught is equal to alpha. So alpha is equal to 1000, and we can calculate out R is equal to 5 ohm. And after that, we need to find VCS, so we apply the formula, and we can find out this. After that, so this thing is Laplace transform, so it will become 1000 E bracket negative 1000 T TU T. And after that, we can find out IL also. So IL is equal to 1000 TE power of negative 1000t. After that, this underdamped. For underdamped, the alpha we need to set that is below than W. So at here alpha I set it as 500, and after my calculation, I know that C is equal same to 0.1 mF, and L I assume the same thing, 10 mF, and after that we can know after with the calculation we can know R equal to 10 ohm. And I apply the equation ILT plus V over R plus C dV over dt equal to 0. And after the calculation, I can find out dV 0 over dt equal to 0 volt. That is initial condition. Then S1 plus and S2 equals to negative alpha plus minus square root W naught minus alpha, W square minus alpha square. So S1 equal to negative 500 plus J square root of 1000 square minus 500 square. And we can get S1 is equal to negative 500 plus J x66.025. So actually S1 and S2 is only the symbol change, plus and minus symbol change. So S2 is negative 500 minus J x66.025. So what's the general solution? General solution, ICT is equal to IL0 equal to 0A. So ILT equal to IS plus A1 cos W alpha t plus A2 sin W alpha t E negative alpha t. So what is W alpha? W alpha is equal to x66.025. So this thing is actually W alpha . And after we sub all the value inside, and we can get A1 is equal to negative 8. I can get this, but after we sub the initial condition t equal to 0, I can get A1 is equal to negative 8. So after that, we need to find the same thing di dt. And ddt is equal to I. So this thing is I, right? This thing is I. And we just using the this formula, di dt is equal to u dv dt plus v du dt. So this thing is okay, so this thing is the product rule. So the product rule, and we can find out is equal to A1 cos x66.025t plus A2 x66.025t times with negative 500 e power negative 500t plus e power negative 500t bracket x66.025 and times with negative A1 sin x66.025t plus A2 cos x66.025t. And after that, we also apply the initial condition, that is, we assume that t equal to 0, so and we can find out negative 500 A1 plus x66.025 A2. After that, we using this formula, VC is equal to L di dt and VCL over L equal to di dt, and we can know that at the initial condition, VC is equal to 0, right, and L is equal to 10M, and we can assume, we can find out that di dt is equal to 0 and then we just sub it inside this equation, and we can find out, since we know A1 is equal to negative 8, and we can find out A2 is equal to negative 4.619. So after that, this IL equation, we just sub the value inside, and VCT is the same thing. We just times 10M is equal to L di dt, and after that, we also sub the value inside, and this is the thing we can get VCT. This is the equation. So after that, we need to do the simulation. So the simulation, I using the this Ni multisim. So at Ni multisim, I just place the component from the Ni multisim. I just play the current source, inductor, capacitor, and resistor, and I set the value that I calculated, and the value change is only the resistor. Others didn't change. After that, I run the simulation. Okay, after I run, I can know that for the V, right, for V1, that is overdamped, so I can know that is a graph. Okay, this is a graph. This is a graph for overdamped. And for V2, this is a critical damp. So this is a graph for critical damp. And so for V3, there is an underdamped. So this is a graph for underdamped. Okay. So this is the simulation, and this is the inductor or the current. Okay, for current at 1. at the overdamped situation, and this is the current for inductor at the critically damped situation, and this is the current for inductor in the underdamped situation. So that's all for my presentation. Thank you, and I will pass it to my teammate.
My name is Rosimin and my metric number is DE230105, and now I want to present about the solution of question 2. Given this circle and also given the value of V source is equal to 20 sine omega t and I source equal to 10 cos omega t, well, omega is equal to 200. And first we solve it by using mesh analysis and we convert the V source and I source into the polar form. And for I source 10 cos omega t, we need to convert it as sine which need to plus 90 degree. And so for the inductor and capacitor, we need to convert it as the phases domain, which inductor is equal to j omega L. And also the capacitor is equal to 1 over j omega C. And after that, we can find it by using Kirchhoff voltage law. We can find for the equation loop 1 is equal to 35 minus j 0.25 I1 minus 25 I2 equals to negative 10. And for the loop 2, the equation is negative 25 I1 plus 25 plus j 0.25 I2 plus j 0.25 I3 equals to 0. And for loop 3, the equation is j 0.25 I2 plus 20 minus j 0.25 I3 equal to negative 20. So after that, we combine these three equations into the metric form, and we can find the value I1, I2, and I3. And to solve this metric, we use Cramer rule, which need to find the value of theta 1, theta 2, and theta 3. So for I1 is equal to theta 1 over theta, I2 equal to theta 2 over theta, and I3 equals to theta 3 over theta. And after we find these three current, we can find the IA, IB, and IC. So for IA is equal to I source minus I1. So the final answer for IA is 10.03 sine 200t plus 84.28 degree ampere. So for the IB is equal to I1 minus I2, which the answer is 0.0201 sine 200t minus 92.01 degree ampere. So for the IC is equal to I2 minus I3, which is equal to 0.045 sine 200t plus 88.71 degree ampere. So the V is equal to negative j 0.25 IC, and we substitute the IC value, we can find that V is equal to 0.01125 sine 200t minus 1.29 degree volt. So second, we did circle by using nodal analysis. So for the node 1, we solve nodal analysis by using Kirchhoff current law, and we determine the current flow. So the node 1, the current is V1 times 32 over 325 minus j 321 over 325 plus V2 times negative 32 over 325 minus j 4 over 325 is equal to j10. And after that, we found the equation for the node 2, which the equation for node 2 is V1 times negative 32 over 325 minus j 4 over 325 plus V2, 9 over 65 minus j 646 over 325 plus V3 times j2 equals to 0. And also the node 3 is equal V2 times j2 plus V3 times 1 over 20 plus j2 equal to 1. And we convert it into metric form. And we can find the V1, V2, and V3 using the Cramer rule also. And we found the theta value, theta 1, and also theta 2 and theta 3. And finally, we can find the value for V1, V2, V3. For V1 is equal to theta 1 over theta, theta V2 is equal to theta 2 over theta, and also V3 is equal to theta 3 over theta. And we can find that the IA, which is equal to V1 over J, based on the Kirchhoff current law. And then we finally got the answer IA is equal to 10.025 sine 200t plus 84.28 degree ampere. And IB is equal to V2 over 25. The answer is 0.02 sine 200t minus 91.28 9 degree ampere, and IC is equal to V3 over negative J 0.25. And the final answer for IC is equal to 0.045 sine 200T plus 89.51 degree ampere. So for the V3, which is equal to the voltage, so the answer is 0.0112 sine 200T minus 0.49 degree volt. And that's all for the solution of question 2.
Alright, so good morning Doctor and hello everyone. My name is Suzy Jen, number 3 is C230078. So today I will present the simulation about the question 2, and this is the question 2 circuit, and I will simulate the steady state current and voltage, which is the IA, IB and IC, and also the voltage VT. So now I will open the Pro Tools, and according to the circuit, so here got the resistor, inductor and also the capacitor, and this one is the meter to get the result, and also the power supply. So now the R1 is 5 ohm, R2 is 10 ohm, and the R3 is 25 ohm, and the R4 is 20 ohm. And for the inductor L1 is 2.5 millifarad, and the L2 inductor 2 is 5 millihenry. And for the capacitor 1 is 4 millifarad, and the capacitor 2 is 20 millifarads. And at the power supply, we need to setting for the frequency is 64, and the VA is equal to 10. For the V1 is we need to setting about the VA is 20 voltage and the frequency is 64 hertz. So now we just put the probe, the IA at here and IB at here, and also the IC. For the VT, we just probe the C2, which is at here until here to get the result. And this 3 is the AC ampere, and for this is AC wattmeter. So now I will show the waveform result, which is the yellow color. This one is IA, and the blue color is VT, and the red color is IC, and the last is the green color is IB. So this is the frequency waveform. The result when we simulate, it will come out like this. So this is my presentation. Thank you very much.